Hi everyone, hope you're doing good. Mechanics of Material, Chapter 1, Stress. Let's review an interesting problem in a simple, interesting problem in stress within a bicycle brake system. So a force of P, this is P equal to 17 newtons applied by a rider to the front hand brake of a bicycle, and P is the resultant of an evenly distributed pressure. Mhm. As the hand brakes pivots at a tension force of T develops in a cable, in a brake cable. So we want to calculate this force. Mhm. A T develops, a tension force developed in a 460 millimeter long brake cable. So this is the brake cable, and this tension induced by this pressure by the rider, by the hand of the rider of the bicycle. If the area is equal to area of the cable is equal to 1.075 millimeters squared, uh, which elongates by a delta of this much, 0.124 millimeters, we want to calculate the normal stress sigma and also strain. So sigma in the cable is T tension force over the area. If we do know what the tension is and divided by the provided area, we can get the stress, and also the strain is nothing but delta over the original length. So delta is provided, original length is 460, and it's already calculated. Let's jump to the problem. So as the rider pushes the brake system, you can easily see there is an evenly distributed pressure goes to the handle of brake, and if we want to and provide and creates a tensile force in the brake cable. If we want to calculate this force, we can easily make a moment about this point, like point A, and get the forces. So summation of moment about A goes 0. It just gives us, we already have the dimensions. So this is 37.5 from here, the vertical distance to point A for tensile force in the cable. And this force is, the dimension is provided. This is 50 millimeters. All way is 100, and the location of the this conversion of distributed to a concentrated load is equal to 15 plus half of this distance, 25 millimeters, which is 75. And if you do so, it just gives you a tensile force in the cable is equal to 140 newtons. Hmm? For calculation of stress, if you simply divide this force by the area of the cable, which is provided in the problem statement, you get 130.2 megapascal in terms of stress. And again, strain is nothing but delta over the original length of the cable. Both of them are provided in problem statement, and it just gives you 4.65 times 10 to negative 4, and this is like a stress and a strain on the cable. We'll solve another problem in a bicycle system in terms of the stress and strain calculation in next video. Thank you.